Good morning, students. Welcome to Bindu Dhadwal Chemistry Lessons. Our topic for today is polymers, and we'll be doing different classifications of polymers. Polymers are one of the most important substances that have a great impact in our modern day life. The man-made fibers are used in textile industries. Nylon and terylene have replaced cotton and silk. Resins, plastics, natural and synthetic rubbers are a gift from the scientists to the society. The first polymer, polyvinyl chloride (PVC), was synthesized in 1838, and the next year styrene was synthesized. Since then, the scientists have not looked back, and apart from polymers, the articles which are not made from polymers will be coated with or held together by polymers. For example, urea formaldehyde polymer Fevicol is used to bind wood pieces together. Melamine formaldehyde polymer is used on wooden doors and windows to impart them durability and shining look. So biopolymers, which are biodegradable in nature, and they are not harmful to our environment in comparison to some non-biodegradable polymers which pollute the environment. For example, polythene bag. Polymers can be divided into different classes of polymers based on the nature of forces present and the mode of synthesis. A few important polymers and their classification is polymers. The word polymers is derived from the Greek word poly meaning many and mers meaning unit. So polymers are substance of a high molecular mass 10 raised to power 3 to 10 raised to power 7 formed by the combination of large number of simple molecules called monomers by chemical bonds, and the process of conversion of monomers to polymers is called polymerization. For example, ethene molecules under conditions of polymerization in presence of oxygen can be converted into a polymer, polyethylene. Polymers, depending upon if the units which are attached together are of the same kind, are called homopolymers, for example polyethylene, and copolymers if the units are different. For example, terylene is a polymer of terephthalic acid and ethylene glycol. These are two different units. And similarly, nylon 6,6 is a polymer of hexamethylene, diamine and adipic acid. These two again are different monomeric units which combine to form polymers. So it's a copolymer. The polymers are different from macromolecules. Macromolecule, for example, chlorophyll is a macromolecule. It has a high molecular mass and a formula C55H72O5N4 Mg, but it does not have any monomeric units, so it's just a macromolecule. It's not a polymer. On the other hand, polythene also has high molecular mass and it's also made up of monomeric units, so it's a polymer as well as macromolecule. Similarly, protein is a polymer as well as macromolecule, has high molecular mass and it's a polymer of alpha amino acids. While all macromolecules may not be polymers, all polymers are macromolecules. Classification of polymers can be made on the basis of source of origin. They can be classified into natural polymers, synthetic polymers and semi-synthetic polymers. Starch, cellulose, protein are examples of natural polymers. Similarly, natural rubber. Polyvinyl chloride, Teflon, Bakelite, terylene are examples of synthetic polymers. These are man-made polymers. Semi-synthetic polymers consist natural raw material, but they are synthesized in factories. For example, cellulose diacetate rayon is a semi-synthetic polymer. Cellulose nitrate, gun cotton, is also semi-synthetic polymer. We can also classify polymers on the basis of structure. If they consist of a single linear chain, then such are called linear chain polymers. In this case, the monomeric units are linked to one another to form long linear chains. The chains are placed one on top of the other, so they are closely packed. So they have high density, high tensile strength, and also high melting and boiling points. The second category is when they have branches also. Because of the branches, they cannot be fitted closely together. So they have low density, low melting and boiling points, and low tensile strength. So these are called branched polymers. Examples are amylopectin, starch, glycogen, etc. Then third category is cross-linked polymers. These are also called network polymers. The monomeric units are linked together to form three-dimensional networks. They are expected to be quite hard, rigid and brittle. Example, bakelite, glyptyl, melamine formaldehydes are cross-linked polymers. Then based on mode of synthesis, they can be classified into addition polymers and condensation polymers. So addition, when the monomeric units are repeatedly added to form long chains without the elimination of any product molecule, they are called addition polymers. They generally have multiple bonds. And when the monomeric units with two or more bifunctional groups join together with the elimination of simple molecules like water, alcohol, ammonia, the reaction is called condensation polymerization, and the polymers who formed is called condensation polymer. And based on the nature of molecular forces, we can classify into elastomers, fibers, thermoplastics, and thermosetting polymers. So addition polymers can be further classified as homopolymers and copolymers. If the units are same, then it's homopolymer. They are performed by the process of step growth polymerization. For example, ethene is added to another ethene molecule, which will in the next step added to another ethene molecule to form polyethene. Similarly, polypropene to polypropylene, styrene to polystyrene. Examples of copolymers: Buna-S is a copolymer of 1,3-butadiene and styrene in the presence of sodium. So the polymer formed is a copolymer because it has two different monomeric units. As a result of addition polymerization, double bond will change into single bonds. This can be done by free radical polymerization, by cationic polymerization, and by anionic polymerization. The free radical polymerization normally occurs at high temperature and under pressure in presence of small amounts of organic peroxides which act as catalyst and help in initiating free radical mechanism. The first step involves the generation of a free radical. For example, a peroxide on homolytic breakage will form alkoxy free radicals. Then second step is growth chain propagation. In this step, the alkoxide ion formed reacts with ethylene molecule to form another free radical. This free radical will combine another ethylene molecule to form a longer chain. In the last step, chain termination occurs where two free radicals may combine. This may occur by coupling, where two free radicals combine to form a longer chain, or disproportionation by giving one hydrogen free radical to another, and as a result an alkene and alkane is formed. Then cationic polymerization normally occurs in the acidic medium in presence of proton acids like sulfuric acid or Lewis acids like aluminum chloride, BF3, etc. Monomers in which the electron releasing groups are present participate in cationic polymerization. So, for example, in isobutylene, there are two methyl free radicals which are electron releasing in nature. In the presence of acid, a cation is formed. This cation will then take up the electrons of another alkene molecule to form a longer chain. This is repeated again to form a polymer. In anionic polymerization, the anionic mechanism is noticed in alkene molecules having some electron withdrawing group, for example, vinyl chloride. In presence of base, the electrons of base will add up to form an carbon ion, which will take up another alkene molecule having an electron withdrawing group and form a longer chain. This on repetition forms the polymer. So different polymers, addition polymers are polyethylene, polypropylene, butadiene, Teflon, PVC, polyisoprene, natural rubber, etc. Then condensation polymerization occurs between monomers containing bifunctional or polyfunctional groups. For example, hexamethylene diamine, the NH2 group will combine with the carboxylic group of adipic acid and will join here with the elimination of water molecule. A CONH linkage is formed, amide linkage is formed. A bigger molecule is formed. In the next step, it adds on to another hexamethylene diamine to form still bigger, and these steps are repeated to form the final polymer. This type is called condensation polymerization. A smaller molecule is removed as molecule of elimination. Then classification based upon nature of molecular forces. We can classify the polymers into elastomers, fibers, thermoplastics and thermosetting plastics. The intermolecular forces in the various polymers are generally the van der Waals forces and hydrogen bonding. They influence certain mechanical properties of polymers such as tensile strength, elasticity, toughness, etc. And these are quite strong in the polymer chain since these bonds extend all along the chain. Longer the chain, greater will be the magnitude of intermolecular forces. Depending upon the magnitude of these forces, these can be classified into elastomers. In these polymers, the intermolecular forces are weakest. As a result, they can be readily stretched by applying small stress and regain their original shape when the stress is removed. The elasticity can be further increased by introducing some cross links in the polymer chains. Natural rubber is the most popular example of elastomer. Other examples are Buna S, Buna N and neoprene. Fibers represent a class of polymer which are thread-like and can be woven into fabrics in a number of ways. They are widely used for making clothes, nets, ropes, gauges, etc. Fibers possess high tensile strength because chain possess strong intermolecular forces such as hydrogen bonding. These forces are also responsible for close packing of the chain. As a result, the fibers are crystalline in nature and have sharp melting points. Nylon 6,6, terylene and polyacryl low nitrile are examples of fibers. Then thermoplastics are linear polymers and have weak van der Waals force acting in the various chains and are intermediate of the forces between elastomers and fibers. When heated, they melt and form a fluid which sets into a hard mass on cooling. Thus, they can be cast into different shapes by using suitable molds. For example, polythene, polystyrene are examples of thermoplastics. These can be used for making buckets, telephone operators, television cabinets, etc. Thermosetting plastics are normally those substances with low molecular masses. When heated, they become hard and infusible due to cross-linking between the polymer chains. As a result, they become three-dimensional in nature and do not melt when heated. Examples are melamine, formaldehyde, urea, formaldehyde, polyurethane, etc. Difference between thermoplastics and thermosetting plastics. Upon heating, thermoplastics soften readily and can regain their shape or even mold upon cooling. Upon heating, they do not soften, and once melted, they cannot be remolded. They contain long-chain linear polymers and are a result of addition polymerization. These are cross-linked in nature and formed by condensation polymerization. They are generally weak, soft, and less brittle. They are hard, strong, and more brittle in nature. That's all in today's video. If you like the video, please do share and subscribe. Thank you. Have a nice day.